Hey guys, bring it in. Everybody, bring it in right here. Get close. Let's touch each other. Hey guys, listen up. Listen up. Listen up. Listen up. Hey, it's the time of day when everyone's feeling a little fatigued, right? No. Just a little bit, right? On that 25 minutes to altitude, let's visualize the perfect skydive. You're way more likely to experience that perfect skydive if you visualize it.
Anybody that wants to do a big tracking dive, we've got one plane full.
We're
looking forward.
Yeah! World record on 3. 1, 2, 3.
World
record!
All right, welcome to our new topic, what are forces? And by the end of this topic, you should be able to define force and be able to give examples of different types of forces, state the units of force, and also draw free body diagrams. Now in this video, we're not going to get to free body diagrams, but we'll do that in class. So you can keep this in mind and write that down. And let's take a look at our first slide. So we're going to look at force and the definition. And in the video we just saw with the skydiving, there were many forces. There was a force of gravity pulling the people down towards Earth. And there was also some friction from the air. And this friction was slowing them down because they were falling through air, so they have to move the air particles aside, and that causes friction. They're sort of rubbing against the air. So if we were to define force, it's basically a push or a pull in its simplest sense. And so there are many examples of forces. A push or a pull, the weight that we were talking about in last class, gravity, friction, magnets and magnetism, and also buoyancy. And buoyancy is one we're going to look at more in the future. So there are many types of forces. Forces are not the same as density. They are not mass. They are not acceleration due to gravity. And they are not volume. So make sure that you understand the difference between these. All of these have something in common. They are measured in newtons. So a force is measured in newtons. And we remember that weight was measured in newtons, but all of these are measured in newtons. All forces are measured in newtons. All forces have a size and a direction. Should fix up my English a little bit. Have a size and direction. And some forces do not touching or contact. So some forces can act on you without touching you. So gravity, when you're falling, nothing's touching you to pull you. Gravity can act without touching you. And same with magnets. You can make magnets move things without directly touching it. But for friction and like weight and a push or a pull, you do have to touch. So some forces are touch forces and some are non-touch forces. Unbalanced forces, so where they don't cancel each other out, cause a change in motion in how you move. So if you have unbalanced forces, it causes objects to speed up or slow down. So you can take a couple minutes now to write that down. And now we're just going to take a quick look at a textbook. And if you want to add some more detail, you can choose to do that. Let me just zoom out here. All right, so we're going to be looking at some forces. So the first thing we're looking at is, what is a force and how does it act on an object? You have probably heard the word force used in conversation. People say, don't force the issue, or our team is a force to be reckoned with. Scientists use the word force. What exactly is a force as it is used in science? A force is a push or a pull. In science, a force is simply a push or a pull. All forces have both a size and a direction. A force can cause an object to change its speed or direction. When you see a change in an object's motion, one or more forces caused the change. The unit used to express force is the Newton. You will learn how to calculate force a little later in this lesson. And actually, you already know how to calculate force for weight, so you already know one of them. Forces exist only when there is an object for them to act on. However, forces do not always cause an object to move. When you sit in a chair, the chair does not move. Your downward force on the chair is balanced by the upward force from the floor. So that's balanced. So if we look here at the picture, draw arrows representing the pushing forces in the image at the left and the pulling forces in the image at the right. Well, you can see here they were hitting, so you have a force, and forces are always represented by arrows. You would draw an arrow this way. With the dog pulling, it would be this way is the force, because he is pulling. So forces we always show by arrows. If we look at this picture here, we can see many forces. We can see the pushing force. We can see the force of gravity pulling the bird down. We can see the force from the ground pushing up on the person so that they can stand on the ground. We call that the normal force. And we also have a force of also gravity pulling down on the airplane. So there are lots of gravities. Or lots of forces, I should say. So a force can act directly on an object. It is not always easy to tell what is exerting a force or what is being acted on by a force. When one object touches or bumps into another object, we say that the objects are in contact with each other. A force exerted during contact between objects is a contact force. Friction is an example of a contact force between two surfaces. Suppose you slide a book across your desk. The amount of friction between the surface of the desk and the book cover determines how easily the book moves. Car tires rely on friction to keep a moving car from sliding off a road. Cars may slide on icy roads because ice lowers the force of friction on the tires. A force can act on an object from a distance. Forces can also act at a distance. One force that acts at a distance is called gravity. When you jump, gravity pulls you back to the ground even though you are not touching Earth. Magnetic force is another example of a force that can act at a distance. Magnetic force can be a push or a pull. A magnet can hold paper to a metal refrigerator door. The magnet touches the paper, not the metal. So the magnetic force is acting on the refrigerator door at a distance. Magnetic force also acts at a distance when the like poles of two magnets push each other apart. A magnet levitation train floats because magnetic forces push the train away from its track. So you can bring these notes to class and we will do some activities with free body diagrams.